Okay, here I am narrating the answer key for this final review test, I guess, worksheet. I'll try to go through this as thoroughly as I can. You are definitely going to have to pause occasionally if I talk too fast to absorb it all, but I don't want to make the tape too long. Here we go. Are these functions, all right? Really, it's a good way to understand it is just think about that vertical line test, okay? And if you just simply think about drawing a vertical line, do you ever hit this in two places? Because a function is a relation where each input, each x value can give you only one unique output or y value, and you just can't have it hit twice. That's why a vertical line would do that. So these are open circles here. Sorry if they're a little bit small on the original. So there's no issues with any vertical line, so this is a big yes, okay? How you write the domain then is really how do you define the allowed inputs? You could simply write x can be anything equal to -6 up and to, but not including +6. This is the way we can do it with inequalities. I didn't call this f of x. I'll try to make it really clear on the test. But f of x then can be equal to 3. That's an output here. I said I'd try to stick to the grid there, whole numbers. It jumps, and then it can be between, but not including 5, all the way up to looks like 7. So f of x then can be greater than but not equal to 5, up to, and including 7. So 3 and then 5 up to 7. Okay, this guy fails at vertical line test, so that's the big negatory on that one. On to the next, we just have lists of ordered pairs. Do remember that there are 4 ways you can represent functions. We can show graphs, we can describe in words, we can list ordered pairs like this, and we can write equations, okay? So looking at this, just would this pass a vertical line test? I did a little mini plot here. If you think about this, you go out to 1, up to 1, out to 2, up to 1. Very boring, constant kind of a function. That does not fail the vertical line test. The domain are the allowed inputs. It looks like it's counting numbers 1 through 5. The output is that very boring 1. For this one, does this pass a vertical line test? Well, yes. If you graph it, you'll see it's going to be kind of just very slowly creeping up. Well, not, what am I saying, slowly? It's, yeah, well, I guess it is slowly. It goes, you have to go out to 10,000 to go up 5. So it does pass a vertical line test. How you give me the domain, I would recommend you just list those numbers. I'm being all fancy mathematical here. Looks like it's powers of 10 with the first exponent 0 on up to 4 with 4 zeros. The range then, the outputs are just 1, 2, 3, 4, and 5. I would call this g of x, I guess, if I need a function for that. The next one, identify the type of function, okay? If you look at this, I just want you to know the vocabulary. Do study that. You should have lots of good words to describe these things. This is a 4th degree polynomial. It has a coefficient, a lead coefficient of -12. The negative sign means that the right hand and left hand open downward. All right. And again, in interest of time, I'm not going to write that all out, but you could on a test write a full sentence about that. Okay. This one is a quadratic polynomial. That means it's a 2nd degree. You don't have to write both. One or the other is fine. It's worth noting that you have some really good techniques for finding zeros without having to consult a graphing calculator. You could use the quadratic formula. This is very simple, easily factored, so the zeros are at +10 and +2. If you thought of this as a parabola, parabolic function, yeah, that's another good word you could write. You could say it's parabolic. Don't panic if you feel like it's hard for you to come up with all these words. Maybe I'd give you a word bank or something, but you should, for review purposes, have the time to kind of come up with some of these words on your own. Here's the equation for the axis of symmetry. You should know that, minus b over 2a. So the axis of symmetry would be x equals 6. Okay. C, and we'll come to that parabolic thing in a minute. All right, so C, this is a rational function. How do you know that? Because the top and the bottom fit the definition of a polynomial. These exponents are nice whole numbers. It can be 0, 1, 2, 3, 4 counting numbers, but no negative exponents, no x's up in the variables, none of that nasty stuff. Once you know it's a rational function, you want to pay attention to when you have the division by 0. So that would be the vertical asymptotes. You can factor this to be x plus 6, x minus 6. So you ask, when is that equal to 0? That's at negative 6. When is that equal to 0? That's at positive 6. Okay, so the vertical asymptotes are those two, 6, negative 6. You do want to try to factor the top. You can take out an x, but that really doesn't help you much because nothing cancels. If something canceled, if there was an x there and we could take out an x and the two x's cancel, that would change it dramatically. You'd have what's called a removable discontinuity or a hole. That's not going to be a major part of this test, but you should just be aware that you should always factor and cancel if you can. Here's a new thing I'm going to try to show you guys. This is a helpful memory device I found. If you can remember this phrase, Bobo Botten eats DC. All right, think about like some big Godzilla type creature eating Washington DC. Bobo Botten is the name. This will help you remember. This is very difficult. Who wins in the battle of the two parts of the fraction, the numerator and the denominator? And what this stands for is bigger on bottom. Okay, that's the Bobo. Bigger on bottom. We're talking about the exponent. If it's bigger on the bottom, then you get 0 as your asymptote. So that O there is really a 0. Okay, if it's bigger on top, so if the exponent is bigger on top, which is true in this case, that exponent is bigger on top, then none. There is no horizontal asymptote. Okay, and then this eats DC part is exponents are the same. That's what that stands for. Okay, so exponents, see, make sure that shows up. Exponents are the same. Then what's true? Divide coefficients. Okay? So memorize that phrase, Bobo Botten eats DC, and you'll never go wrong. In this case, if that had been a 3 down there, so that means that's the exponents are the same, then just divide coefficients, 2 divided by 1, and that would give you a horizontal asymptote of 2. We'll come up to this again in a second. Okay, save that little memory trick. Here, when we're plugging in and evaluating these functions, just go very carefully. F of negative 1, I plug in negative 1, raise that to an even power, makes it positive, so negative 12 stays negative 12. 3 times 1 is 3. I'm just gathering up the two negatives to make 14 and the two positives to make 13. When I add those, I get negative 1. I think that's maybe the easiest way to do that. Again, just go slowly. G of negative 10. Negative 10 squared is positive 100. Negative 10 times negative 12 gives you a positive 120. Plus 20 is 240. And then finally, when we're plugging in these guys, we again just want to go very carefully, paying attention to our exponents. 5 to the third is 125, doubled is 250, plus 5 gives me 255 over negative 11. Negative 11, be careful there. That's negative 23 and 2/11. And then finally, f of g, g of f of 0. F of 0 is just going to drop out everything but the negative 2. And then when you square it, it becomes positive 4, and you multiply negative 2 times negative 12, you get 24, and your final answer, 48. Okay? So there's the first page. On to the calculator stuff.